All right, so our first problem here is we're not actually going to come up with a expression for a current or voltage. This is just to practice finding the various different things that you might need to find if you're looking at an RLC circuit. So we have a circuit and we say it closes at t equals 0. Draw the configurations that appropriately represent the state of the circuit at t equals 0 minus, t equals 0, and t equals infinity, and use them to determine all of these things. So the key thing to remember when you're doing these, and this is always true, so look at t less than 0 to find IL of 0 and VC of 0. Use t greater than 0 to find IC of 0 and VL of 0. And not only that, when looking at t equals 0, the values of IL of 0 minus and VC of 0 minus must still be true. So in other words, what you do is you look at it before 0, you find IL of 0 and VC of 0. You've got those. Now you look at, okay, now I'm closing the switch, but you know those two values that you found, those are still true. So you can fill those in and then find the other stuff. And then infinity is going to be something different. So that's what we're going to do here. Okay. So first we'll look at t equals 0 minus or t less than 0. Okay, so that's the way it's drawn here. So we have our voltage source and a resistor, and our inductor will act like a short circuit, and our capacitor will act like an open circuit, and our switch is open, so there's nothing going on there. So we don't have a complete circuit. So since we don't have a complete circuit, then there's no current anywhere. But in particular, remember what we're finding with this stage. The two things we're finding at this stage are IL of 0 and VC of 0. So IL of 0 is 0 because there is no current. So that one we're okay with. But VC of 0, you can have a voltage even if you don't have a current, and that's what's true here. Because if we look, we have our 12-volt voltage source over here. There's no current anywhere, and so there's no current going through the resistors, so the voltage doesn't change through those resistors. Our capacitor is in parallel with that 12-volt voltage source, and so our capacitor is labeled like this, and that's VC. And so VC also has to be 12. So VC of 0 has to be 12. Okay, so now let's look at t equals 0. So at t equals 0, we close the switch. Okay, I didn't actually Okay, that explains it. It's like, I don't remember doing this because I did not practice that. Okay. So now we want to look at what we have here. So we have to remember, and this is the tricky part, we have to remember that what we found over here, the IL of 0 equals 0 and VC of 0 equals 12, that's really important, that still has to be true. So this still has to be 12 volts over here. And we still have to have a current equaling 0 right there. So if this is 12 volts and our current here is 0, if I call this ground, then if I look at this 4 ohm resistor right here, then this side of the 4 ohm resistor is at 12 volts, and this side of the 4 ohm resistor is at 0 volts. Current through a resistor is going to go from the high voltage side to the low voltage side, and we know there's no current going through the inductor. So all of the current has to go this way. We can't have any current in the left-hand branch at all, because if we had any current in the left-hand branch, it would go through that inductor. Now this is just exactly at t equals 0. If you get a little bit past 0, that's going to be different. So what has to be happening is our current has to be going through the resistor like this, and then back up through the capacitor like that. And then if I write V equals IR, and I'm looking at our resistor right here, that's the voltage is 12, and our resistance is 3, or 4. And so I have I equals 3 amps. But I need to be careful about the current that I solved for. I solved for the current through the resistor. That is the same as the current through the capacitor, but I want to look at how it's labeled in the picture, what it asked me to find. It labeled IC going this way, and we know that the current's really going up. So the answer to what IC of 0 is negative 3. Negative 3 amps.
But so IL of 0 and VC of 0 those are still true at 0 and 12?
IL of 0 is still 0. VC of 0 is still 12. Now, we do have to decide on VL of 0. So let's look at VL of 0. And VL of 0, right now, there is no current flowing through it. And so if there's no current flowing through it, that means that if we're calling the bottom ground, and this is 12 volts, and there's no current over here, then everything above, I think I labeled this backwards, that's plus and that's minus. Everything above this voltage source is at 12 volts. That's all at 12 volts. So this side is at 0 volts, and this side is at 12 volts. Now let's look at how it's labeled. It's labeled with this side being plus and that minus. So we would say that VL of 0 equals 12 volts.
And this is just as we switch it off?
Instantaneously, right as you flip the switch.
So before that, with the first one we did when it was before the switch was flipped at 0 minus?
Yes.
Was our IC and VL both 0?
Yes, yes. No. At 0 minus, so IC of 0 minus is 0, and VL of 0 minus is 0. Right, but those changed because they can. Yeah, but very good question. It took me forever to really, have to think about it a lot to get it. Okay, so now let's look at infinity. And so at infinity, our inductor will be a short circuit, and our capacitor will be an open circuit. And so we won't have, and what are we supposed to find? We're supposed to find VC at infinity and IL at infinity. Okay, so VC at infinity. All right, so let's look at infinity. Our capacitor is in parallel with the short circuit,
Yes.
and the voltage across the short circuit is 0.
Yes.
And IL at infinity, well, we do have a current. We have a current that's a very simple current just going through this left-hand branch here. So we have, this voltage is 12 volts. And we have a 3 ohm resistor. So, yep. So, IL at infinity is 4 amps, and I think we had it drawn this way, and that's the way it's going.